Hi friends, welcome on board for another project. Look at this exciting dual rail output power supply. You can simply connect your center tapped AC transformer to this input terminal, for example one of these toroidal AC transformers. Of course you are not bounded to use this type of transformer, but toroidal transformers are better in performance. And you will get dual rail, positive and negative supply rails from the output, and you can get up to 3 or 4 amps continuously if you use good heat sinks for these two transistors. The output voltage have very low noise because I have implemented the capacitance multiplier concept for this circuit, and also I paid a high attention for good grounding. The top layer is almost a solid ground plane, and look at the bottom layer. As you can see, the quality of the PCB is very nice. So later on I will tell you how you can order such a PCB or even the assembled board for a good price from the PCBWay website. Let me explain the board just briefly. In the next step I will go through the schematic and PCB. So as I told you, this is the input terminal and this one is the bridge rectifier, and these 4 capacitors are for noise reduction at the input. And each of these 2 capacitors are in parallel. So why? Because when you put capacitors in parallel, it helps to reduce the ESR, because the result ESR of these 2 capacitors are like 2 resistors in parallel. So the result of the ESR is lower. The rest is the implementation of the capacitance multiplier circuit, and here is the output filtering and the dummy load for the output. Here is the bottom layer, as I told you. So nothing very much remains here. In the next step I will go through the schematic and PCB. Stay tuned. Alright, here is the schematic diagram, and this one is the PCB layout. As you know, with each project I also publish an article, so just follow this link in my YouTube video description and read the article. You can find a full description of the schematic, PCB, how you can download the Gerber, how you can order the PCB or the assembled board. Also more information regarding the PCB and other components. So I just skipped the schematic. Here is the PCB layout. Let me show you the board size here. Horizontal size is around 12 centimeters and vertical size is around 6 centimeters. So it's somehow compact board, although I have used through-hole components. So even if you are a beginner, you should be able to solder and build this design and use it as your power source. I have followed some PCB design rules to draw this PCB. Let me start with the bottom layer. This circuit can handle up to 3 or 4 amps continuously. So using a ground or the power plane instead of track is the only solution to design such boards, because if you see how you can implement a fat track from this transistor to this output terminal. However, a power plane is a feasible or is the best solution to reduce the resistance of the track to carry a high amount of current, and your design looks much more professional. I think even for this design it's not possible to implement a fat track from here to here. Do you see? Because this path should come from here to the middle pin of the transistor. So a plane is the only solution, and you can implement these planes using polygons. The next thing is the grounding. So you can see the grounding of the bottom layer in the middle of the board. However, the good thing is the top layer. The top layer is a solid ground plane without any track or any interruption in the ground plane. It's difficult to build this in a 2 layers PCB board. However, for this design it was possible. If your design is more complex, you have to at least go for full layers board and assign one layer just for ground. This helps to reduce the length of the ground path and minimizes the noise. I will show you the output noise in the next section or in the last section, at which the output noise is even you are not able to measure the output noise because it's very low. The last technique is using these vias or wires. These vias also help to reduce the length of the ground path and shorten the ground path as much as possible. So I have implemented this group of vias in this pattern, here, 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 and in these two areas. I think I covered most of the points. In the next step, I will show you how you can order the PCB by using the Gerber file. Alright, here is my account on the PCBWay website. If you are new here and just create a new account, I think they offer a $5 gift to order the PCBs and so on. Also, I see some special offers for the Christmas, 50% off. So if you have some projects, I suggest you to use this opportunity and reduce your production costs. Anyway, in your account, just click the second tab. It says PCB stand quote. And you will see this nice calculator. One option is to fill out this calculator yourself. However, if you come here and it says quick order PCB, and here you can upload your Gerber file. Here is my sample Gerber. And it nicely detects the board size and all of the options, all of the best options for your special PCB or your special design. And it says it just takes 24 hours to fabricate this PCB for the quantity of 5. I think if I increase this to 10, the price is even identical. Yes, for the quantity of 10, the fabrication cost is just $5 also. I think it's because the total size is less than, each dimension is less than 10 centimeter, which is true for this PCB, my sample PCB. You can change all of these options also. It's a complete user-friendly website. Really, I like that. And here you can calculate your shipping costs. For example, the shipping cost to the United States. It offers all of the shippings here. I think all of the carriers are listed here. So if you don't like the DHL, you can use FedEx, EMS, and I think even the China Post. Yes, even the China Post, or here USPS is just around $10. So if you are hurry, you can use DHL. Anyway, I don't go to save to cart because this is just sample. So did you see? As easy as you saw here. Alright, welcome to the test bench. As you can see, I have prepared a basic test setup using a DC load and an oscilloscope. I had to reduce the exposure of the camera because the device screens are bright, so I had to make it a little bit darker to capture the devices sharply. For the first test, I have connected this transformer to this power supply, and this transformer handles 28 volts AC at the output. So 28, 0 volts and 28, and the output of the power supply goes to the DC load. So the DC value of this 28 volts AC is around 34 volts DC. Now I'm gonna apply the maximum load to the output. My transformer is just 3 amps AC, so I cannot go higher than 3 amps, and also because I have not mounted a heatsink on the output transistors. However, this circuit can handle up to 4 amps continuously. There is nothing wrong with that, no problem with 4 amps continuously. So let me apply the 3 amps to the output and show you the output drop. So the output drops to the voltage of the transformer, around 27 volts DC. I cannot keep it for a long time because, as I said, the transistors don't have any heatsink. For the next test, I will connect this 35 volts AC transformer to the circuit. So the input is 220 volts, mains volts, and the output is center tapped 35 volts. However, this output voltage is for 220 volts. If the input voltage or the mains voltage is higher, you should be careful when using higher voltages because the capacitors are rated at 50 volts. So don't forget this important point. So I just stop the camera and connect the new transformer to the circuit. Alright, I have connected the second transformer to the input. The output voltage of the transformer is 35 volts AC, of course center tapped, and here is the output, around 42 volts DC. This transformer is also around 3 amps of current, can handle up to 3 amps of current. So let me apply 3 amps to the output. So the output voltage is around 34 volts DC. As I said, I cannot keep it for a long time because I have not mounted any heatsink on the output transistor. It gets very hot and it will be damaged. In the next step, I will check the output noise, and the output noise is extremely low. Stay tuned. Alright, before measuring the output noise of the power supply, I decided to measure the voltage drop across the capacitance multiplier circuit because I'm sure many viewers like this measurement. So I put one of the probes at the positive output and another probe at the positive output of the bridge rectifier, and it says 2.5 volts voltage drop across the capacitance multiplier circuit. So it's a very good voltage drop. Alright, here is the oscilloscope screen, and this is my probe, and you can see the ground spring on the top. The probe has been connected to the channel 1, and channel 1 is times 10, and the bandwidth is limited to 20 MHz. Before connecting the probe to the output, I can see it says around 6 or 10 millivolts peak to peak. This is the noise that the oscilloscope detects. Maybe this is the noise floor of the oscilloscope itself. I will perform 2 tests. One, the output noise under no load, and the second, the output noise under the maximum load. So let me put the probe on the output for the first test. And here it is. So I don't see any change in the value of the peak-to-peak noise. So what can I say? Low noise, very little noise, or no noise? Let's say low noise at the output because I cannot measure it using my tool. Let me apply 3 amps load to the output. And here it is. This is 3 amps. Again, I cannot pick any noise at the output with my device. So let's say very low noise at the output. Let me turn off the load because the transistor does not have any heatsink. So what we can say, you can use this circuit for your sensitive application, for your power amplifier that needs dual rail power at the input, and for your sensitive circuits that needs very low noise power supply. I hope you liked this video. Don't forget to give me a big thumbs up and share this project with your friends. We will do something else in the next video. See you next time.